Okay, in the last video, I was thinking through entities that you set when you design versus entities that you move around when you play. So it seems like we need an alternate way of keeping the temporary changes. So we know that a space has many entities, and we have a table for entities. And an entity has many components to keep track of position, rotation, color, all of that kind of stuff. And as a host, you can modify those entities, create them or delete them, or update the components for those entities. And as a player, you might be able to temporarily delete something, as in pick it up, like ammo, and it disappears from the scene. And maybe that's modifying the visibility component, because maybe you're going to bring it back, and then you can update components. So it doesn't look like you'll actually need to override entities. You can't create any new entities or really remove them, because you can just change the visibility. So really, we kind of just need overriding components. And maybe these are just components themselves, just marked with a different kind of type on them. So what do we need to do? Maybe we need to extend the types for overrides. That way we can just efficiently get all the components for an entity, and then when it's time to reset the scene, we can delete all components that have a particular flag on them. For example, let's take a look at the model. Here's the table for the components. So a component has some ID, randomly generated. It has some type, and it has the data, and it references the ID. So maybe you could have a flag in here that is a Boolean for override. I add override, and it's a Boolean. Null is false. The default is false. Okay. Maybe we could start with that. And the point of all this might be our first objective, which is to create a Doom-like game. And if we don't worry about keys and doors, right now the parts that we have are you can have a gun, and you can shoot something, and you kind of have an enemy. The enemy doesn't work too well right now because it's client-based, so multiple people don't see the enemy in the same place. And so some of the events are edit-based, because we have these type of events. So we can say that some of these are in play. Somebody changed a nickname or microphone preference. We're saying that they entered or observed or moved or left. And then these are sort of edit-based things. Entity created, transform, color deleted. And then these are sort of edit and play. Somebody grabbed it, somebody released it. Depending on their mode, maybe we should make a distinction between when you're grabbing this for editing and when you're grabbing this for playing. And then this is when you're shooting a gun. This is when you're getting damaged. And so we don't have one for placing an AI agent. Like we could have one, I don't think we're using this for anything, but you could, I think maybe we are. Maybe you could have one for message is enemy placed. And the payload could be who placed it, and a position rotation. For the enemy, and it's just put there. And so if you're in edit mode, that's just a fact. You're just changing the data of the scene. You say you have an enemy here. But as you play it, that enemy moves itself. And so that position won't be the position that you put there. But as a designer, you definitely do want to put it there. You don't want to have it killed and removed. It's part of your design. And when you're designing, you don't want it to have it attack you. So we can have an alternate set of movements that are coordinated between client and server. And this might be, maybe we call them agent. Agent moved. Okay, so I think we need an agent ID. So we're going to need agent ID. So when you say agent moved, we'll have the agent ID and the new pause route. I also think maybe this could be move to with some speed, because we might not have millisecond to millisecond movement on it. In fact, maybe you give it the agent move to. Maybe we could give it the plans like this. I'm not sure. Something like that. And then agent destroyed, or agent removed. And it's the agent ID. So now we have some agent events. And we don't quite have a UI to place these things, but we do have GraphQL, which can serve as a temporary UI for testing. But our GraphQL is sort of sparse, so we can fill in missing GraphQL operations. let's take a look at our schema. So we have the object space event stream. And this no longer gets you all of the events. This gives you the events that you have in the table, but not all of them. So maybe we have to do it to do get all events from S3 now. Space inputs to create a space. You have some settings here, which we may move these out sometime. Okay, then we have entity and we have the components. But we do, okay, so we have query, and then we have some mutations. You can update space attributes, create an entity for a space, you can delete an entity from a space, play back a stream. So I think we want some of these, or all of these. So we have this one, entity created. That's here. Create entity, and it goes into the space result, create entity, and then we find the space ID, and then we call a command handler create entity. Okay, and then this formulates a place to put it. So the command handler has something that creates the events for us. Okay, we can at least put some of these in. We can do an entity transformed. What do we need here? We need a list of components. And we would just need to create the event, which is space ID. The message would be entity transformed. ID would be the entity ID. Timestamp is that, and components. Oh wait. Oh yeah. Payload. Components are a list of components. And hopefully these are well formed. What are components? Components are something with a type and data object. So nothing on here is about override. We could put it in the data column. Type, position. It's like the only thing you could modify in play mode is its location and visibility. In playing, you can't even edit its scaling unless you're editing. Unless it's a game feature. I suppose you could end up editing anything, depending on the game mechanics. But since the primary key is actually on the type, maybe we should just have something be override position, in which case this would not be here, but it would just be in the type, so you don't have to change this model. Okay. Right, that does that one. So we have a transform entity, but we don't quite, it's not as friendly. So I think this might be used by, perhaps, you need an input for it. So let's see. In the schemas, if we're going to transform an entity, transform an entity in a space, the field is transform entity, and get back a boolean, sure. And you're going to need these things as well. The ID of the space, the entity you want to transform, and we'll pick a resolver. This will be transform entity. Is it 4? I haven't created it yet. Right. Create entity, delete entity, and you need to give it some arguments. So we have some input types, objects and input objects. Let's put all the objects up top, input objects below. Queries. And these are the arguments here for the query. To do a mutation, we've got arg, this and that. Okay, so yes, this arg. Yes, and then we're going to need one more arg, which is component. So we need an input component type. Similar to how we did this space input thing. So we need a component input. Input object is a component input. Field type is string, and data is a component data. And input object component data is field with the value key. This can be, this can be anything. This could be problematic. Let's see, GraphQL schema allow input object any type. have to create a custom converter. Unless you create this into, set this into a string. So it might be easier not to have a transform method here, but you actually have to move it. So we won't have transform entity, we can have translate, rotate, and scale. Translate entity. And we'll give the new position as a position rotation. Input object position rotation, and it has a position which is how do you say, array of numbers, list of number float and rotation, which is a list of floats. And then you can have a translate input, which is actually, you don't need this, just give it the pause drop. Translate entity, give me the entity, finally the position and rotation of where to move. This can be a pause rot, and it's a non-null pause rot. Pause rot input. Then this goes into translate entity space resolver 3. And go down to here, copy this, translate entity, we'll get this, and then we'll get pause rot, get space by the ID. If there's a space, get the entity by the ID. If there's the entity, then we'll transform the entity, sending in the components, which is an array of type, which is position and the data, which is a map with a value key, and this is the oh, we don't need a rotation, we just need the position, so this can just be the position. Position. And in fact, I don't need another type for this. So if we go back to the schema, I just need the position non-null list of float. Alright, so this takes a position, goes to space resolver, translate entity takes the position and forwards it to the command handler, which actually does transform entity, converting it into the component that it needs. Yeah, a single component, here it is. And that is it, I think. Then command handler will just create the event. So we can further create rotate entity, be a similar thing. It's a little redundant, but it's clear. Set the type, scale, scaling. Scale, entity, scale, scale, this is called scaling. This can be rotate, rotate. Let's call it scaling. Scaling. If that's called scaling, this is called scaling. This is called scaling. And this is called scaling. Okay, we're good. And let's test it out. Okay, they have them here. So we load up a space. Okay, there is a thing here. What's the ID for this? Query. No, let's do a mutation. No. We need to know what the entity ID is. So query the space, get back the entity, and I want the ID and the type. For entities. Entities. Oh, entities, ID, name, type. Okay, the cylinder has this ID. Now we want to mutate it. So mutation. And yes, let's try to rotate entity. We need the entity ID, and we also need the space ID. Do we need this entity ID? It's probably good for completeness just to specify which space you're talking about. Space ID is, of course, that space ID, 1D. And then we need the rotation, which can be 0.2, 0.3, 0.5. I have no idea what that'll do. But, whoa. No function calls matching resolvers, space resolver translate entity 3. There's no function calls for a translate entity 3. Space resolver translate entity 3. It's right here. Oh, haha. Should be rotate. Oh, it should no. Space resolver. Now rotate entity and scale entity. Okay, rotated it. There we go. Did you get rotated? You did not. Let's try it again. Okay, insert into event streams. Yes, okay, I think server wasn't started before. There we go. Yep. Okay, so we need to get back a false if you can't do that. Actually, we can always send the message in. It just won't be processed if it will be processed. We don't need the server to be alive for this. And it's persisted, right? Yeah, it is persisted. And we can scale this too. So we can scale the entity. And scale entity. Scaling will be so it'll shrink on some dimensions. So if we do that, yeah, and translate. Translate to a position, and this will just be moving it higher. Okay. Works. So we'll continue to flush out the GraphQL API so it matches more closely the things we can do. The point being is we'll have a way to place an agent into the scene without requiring UI menu, and this is something we should build up alongside. Anyway,